Welcome to the Deep Dive, the place where we cut through the noise of technical documentation to deliver strategic, actionable intelligence directly to you.
And today we're really focusing on those of you making the critical security decisions. I mean, the challenge is huge, right? Protecting financial data, trade secrets, credit card numbers, health records.
And it's everywhere. It's not just sitting on a server anymore. It's in emails, shared drives, cloud apps, personal devices, even those new AI tools people are using.
Exactly. That fragmentation is a real headache. And look, the stats back it up. Our sources show 74% of organizations had some kind of business data incident last year. 74%.
That's staggering. But here's the part that really caught my eye for strategy. Organizations juggling lots of different disconnected security tools. They actually had 2.8 times more incidents.
Right. More tools, more problems, apparently. Which leads us nicely into our mission for this deep dive. We're going to unpack Microsoft Purview Data Loss Prevention, or DLP.
The idea being it's a single unified way to stop sensitive data from walking out the door, whether someone's trying to share it, use it improperly, or just transfer it somewhere it shouldn't be.
Exactly. It offers customizable policies, real-time monitoring, all aimed at managing that sprawl from one place.
And it's important, I think, for everyone managing their security posture to see where this fits. DLP isn't standalone. It's a key piece of the bigger Microsoft Purview puzzle, working alongside things like information protection for classifying data and insider risk management for spotting risky behaviors.
Absolutely. They all work together. So let's start with the core function. What is DLP, fundamentally?
Okay, basics first.
Well, at its heart, it's about identifying, monitoring, and crucially, automatically protecting sensitive data wherever it is. And that means in 3 states.
3 states.
Yeah. Data at rest, think stored files, maybe in SharePoint or on someone's laptop. Data in motion, that's data zipping across the network, like in an email or a Teams message. And data in use, that's when a user is actively working with the data on their machine.
Got it. Stored, moving, being used. So given today's, hybrid world, where does Purview DLP actually enforce these rules? The coverage has to be pretty broad.
Oh, it is, and that breadth is really key. First, you've got your core Microsoft 365 services. So Exchange Online Email, SharePoint sites, OneDrive files, Teams chats, and channels.
Standard stuff.
Right. But also, and this is increasingly critical, Fabric and Power BI workspaces. And even interactions with Microsoft 365 Copilot, though that part's still in preview.
Okay, so that's the Microsoft Cloud covered. What about outside that? Laptops, other cloud apps?
Good question. For endpoints, it covers Windows 10, Windows 11, and the 3 latest Mac OS versions. And importantly, it protects data even if the device is offline.
Offline protection, that's huge for royal workforces.
Definitely. But for your hybrid setups, it reaches into on-premises file shares and on-prem SharePoint servers. And maybe the most expansive part is its integration with Microsoft Defender for cloud apps.
Ah, the cloud app security broker connection.
Exactly. Through that, DLP policies can extend to, get this, over 34,000 non-Microsoft Cloud apps. Think Salesforce, Dropbox, ServiceNow. The list goes on.
34,000 apps. Wow. Okay, that scope is massive. So how does it actually know if something is sensitive? It can't just be scanning for keywords like confidential, can it? That would generate so much noise.
No, you're right. It's much more sophisticated. Purview DLP uses what's called deep content analysis. It's not just simple text matching.
Deep content analysis. What does that involve?
Well, it looks for primary evidence, maybe a keyword or a specific pattern like a credit card number format found using regular expressions. But then crucially, it looks for secondary corroborating evidence nearby.
Ah, so like finding a credit card number and an expiry date close together.
Exactly. The contextual proximity is key. It also uses internal function validation, like checksums for credit card numbers, to verify the pattern is legitimate.
Okay, so it's not just the pattern, but validating the pattern and looking for related info nearby. That must seriously cut down on false positives.
It does, significantly. And on top of that, there are machine learning algorithms trained to recognize sensitive content patterns, even if they're slightly disguised or formatted unusually.
All right, so the tech is smart, but smart tech needs smart planning. If you're an IT leader about to roll out rules that could affect thousands of users, where do you even start? How do you avoid chaos?
Planning is absolutely paramount. And it starts with something called a policy intent statement. You have to clearly define the business need first.
A policy intent statement sounds formal.
It is, and it should be. It's the documented agreement on why this policy exists, what specific risk it addresses, and what sensitive data you're targeting. If you skip this step, you're basically just guessing with the settings, tuning by trial and error.
Which inevitably breaks something or annoys everyone.
Precisely. And leads to costly business disruptions. You need that roadmap.
And who needs to be in the room or virtual room to create this roadmap? It can't just be the IT security folks.
Right. Absolutely not. You need your regulatory or compliance officers, the people who live and breathe GDPR, UCPA, CCPA, whatever applies. You need legal involved.
Yeah.
You definitely need the business owners who actually understand how this data flows day to day. And, of course, the security officers.
So a cross-functional team. What's the main output they need to agree on in that statement?
One of the most critical things, beyond the what and where, is defining the organization's actual calculated tolerance for sensitive data leakage.
Tolerance for leakage, that sounds counterintuitive. Isn't the goal zero leakage?
Ideally, maybe, but practically, achieving absolute zero can be incredibly expensive and might cripple legitimate business processes. So you need to define upfront what level of risk is acceptable for specific data types or scenarios. That drives everything.
Okay, that's a really important strategic point. Define the acceptable risk threshold first. Let's make this concrete. Say we use that IPA example from the source docs. How does the intent statement translate into actual policy setting?
Okay, let's say the intent is we have a very low tolerance for potentially leaking patient identifiers associated with prescriptions, especially outside the organization via Teams or shared files.
Right. So step one in the policy config, what to monitor.
You'd likely start with the built-in U.S. Health Insurance Act, HIPAA, template, which knows about common health identifiers, and you'd target, say, office documents.
Makes sense. Step two, conditions for a match. What makes it sensitive in this context?
Here's where it gets specific. The policy might require finding both a U.S. Social Security number and a Drug Enforcement Agency, or DEA, number within the same document. The DEA number is key because it links directly to controlled substance prescribing.
Okay, so SSM plus DEA number. What else?
And the condition might be that the content is being shared outside the organization. This is where your risk tolerance comes in again. Is one instance of this data shared externally enough to trigger the policy? Or maybe you set a higher instance count.
Got it. Then step three, where to monitor. Location scoping.
Based on our intent, we'd scope this to SharePoint sites, OneDrive accounts, and Teams chat and channel messages.
And finally, step four, actions to take. What happens when a match occurs?
Actions could range from just auditing to blocking the share, restricting access only to certain people, or even automatically applying encryption to the document.
That structure seems pretty logical for turning rules like keep high into actual technical controls. What about really complex scenarios, maybe exceptions for specific departments, talking to specific partners?
Yeah, the rule builder is quite powerful. You can use Boolean logic, AND, or not T, and even group conditions together. So you could say, for example, block emails with credit card numbers or are emails tagged with the highly confidential sensitivity label.
Okay.
But not if the email is sent from someone in the finance group to a specific approved external auditor's domain. You could build that kind of nuanced logic.
That level of granularity is essential. Okay, so you've planned, you've defined the intent, you've built the rules. Now, deployment. You mentioned avoiding chaos. How do you roll this out without grinding productivity to a halt?
This is where the incremental deployment strategy is absolutely critical.
Yeah.
Manage the rollout carefully using three main levers you can adjust anytime. The scope, who it applies to, the policy state, how active the policy is, and the actions, what it actually does.
Right, those three axes. Let's focus on the policy state first. That seems like the core of the gradual rollout. What are the stages?
You start with the policy state set to keep it off. This is while you're still building, refining, maybe doing initial tests with IT. No impact on users yet.
Okay, stage one, off.
Then you move to run the policy in simulation mode. This is huge. The policy evaluates everything as if it were live, but it doesn't actually do anything to stop the user. No blocks, no warnings.
Ah, so it's just logging potential violations silently in the background.
Exactly. All the events that would have triggered an action are recorded in the audit log and Activity Explorer. This gives you invaluable data on how often the policy would fire and who it would affect without any disruption. Pure intelligence gathering.
That sounds like a much safer way to start. What's next after simulation?
The next step is run the policy in simulation mode and show policy tips. Still no blocking actions are enforced. But now, users start seeing notifications or policy tips when they're about to do something that violates the policy.
So it's like, hey, you probably shouldn't share this document externally because it contains sensitive info. But it doesn't stop them yet.
Correct. It serves as user education and awareness. And this is the perfect stage to narrow the scope to a specific pilot group, maybe a tech-savvy department or set of friendlies. You get direct feedback on the tips, on false positives, before wider impact.
Collect feedback, tune the rules based on the simulation data and pilot feedback.
And then?
And then, once you're confident the policy is well-tuned and users understand it, you move to the final state. Turn it on right away. Now the policy is fully enforced, applying the actions you configured, like blocking or restricting access.
Okay, that phased approach makes a lot of sense. Now let's talk about those actions. You mentioned different levels of control. What are the options there, starting from least restrictive? Well, the absolute least restrictive is essentially audit only, or allow on devices. It just logs the activity, zero user impact, purely for monitoring.
Okay, baseline data gathering.
Then you have block with override. This is strategically very interesting. The policy blocks the action by default, say, sending an email with sensitive data externally. But the user is given an option to override the block, usually by providing a business justification in a pop-up. I need to send this to our legal counsel for review, something like that.
Why is that override option so valuable? Doesn't it weaken the policy?
You might think so, but it's actually incredibly valuable for tuning. Those justifications are logged. They give the security team immediate, context-rich feedback directly from the user about why they needed to perform that action. It helps you rapidly identify legitimate business processes you might have accidentally blocked, or find rules that are triggering incorrectly, false positives.
Ah, I see. So instead of users just getting frustrated and finding insecure workarounds, they're actually giving you data to make the policy smarter. That's clever.
It really is. It turns potential friction into a feedback loop. And then, of course, the most restrictive action is just block. No override, the action is stopped, period.
Okay, so review off, simulate with tips for a pilot, tune, get feedback, maybe develop some super users, then turn it on fully, potentially starting with block with override before going to full block if needed.
That's the recommended path for minimizing disruption and maximizing effectiveness.
We mentioned offline protection earlier. If a device is offline, how does it get policy updates? And does running DLP locally impact the machine's performance much?
Good points. Policies are actually cached on the endpoint itself. When the device connects to the network, it synchronizes for any updates. Regarding performance, the impact is generally designed to be minimal for typical user activity.
But if someone's, say, copying massive sensitive files locally?
Yeah, intensive file operations involving sensitive data might see a brief resource spike as the content is scanned by the DLP engine. That's why monitoring endpoint activity in the reporting tools and ensuring your policies are tightly scoped is important. You don't want to scan everything unnecessarily.
Right, continuous monitoring. Once these policies are live, where do IT teams go to see what's happening? Where's the central dashboard for this?
All the activity ultimately flows into the Microsoft 365 audit log, which is the central repository. But for DLP-specific insights, there are a few key places in the Purview portal.
Okay, where should they look first?
For a high-level overview of potential risks, I'd point you to a dashboard card, often titled something like High Volume of Sensitive Info Shared or Saved Externally.
And what's special about that card?
What's really useful is that this card can highlight risky user activities, like someone uploading tons of files to a personal cloud storage site, or copying data to USB drives, even if you don't have a specific DLP policy configured to block that yet. It gives you baseline visibility into potential exfiltration patterns.
That's handy proactive threat hunting without a specific policy match needed. Now, when a policy does get triggered, where do those specific violation alerts show up?
Those generate DLP alerts. You'll find these in the Purview DLP alerts dashboard. Now, there's a key detail here regarding retention.
Oh, what's that?
Alerts are visible in that dedicated Purview DLP dashboard for 30 days. However, these alerts are also routed to the broader Microsoft Defender portal, and over there, they're kept for 6 months.
30 days versus 6 months. Why the difference? Is the Defender portal the place for longer-term investigations?
Exactly. 30 days might be fine for quick operational checks, but for serious incident response or compliance reporting that might look back several months, that 6-month retention in Defender is crucial.
Got it. So Purview for recent alerts, Defender for the longer history. What about the deep dive tuning? Where do you go for the really granular details on policy matches?
For that, the Activity Explorer is your primary tool. It lets you filter and investigate DLP policy matches, endpoint activities, data egress events, all within the last 30 days. It's essential for understanding why a policy triggered and if it needs adjustment.
And when you're digging into a specific incident in Activity Explorer, what information do you need to piece together?
You really need to look at two related events to get the full picture. First is the DL match event. This is critical because it actually contains snippets of the text around the sensitive information that caused the match.
Ah, so you see the context, not just that something matched.
Precisely. And you need to pair that with the related user activity event that tells you who did it, what action they were attempting, like SharePoint file shared externally, which specific policy fired, and what action was taken.
Context plus activity equals understanding.
Right. And analyzing that paired data is the foundation of continuous tuning, refining rules, adjusting scope, making sure you're not blocking legitimate work while still catching the real risks.
It really paints a picture of Purview DLP as more than just a gatekeeper. It seems to be about unifying policy management everywhere, giving you flexible controls like that block with override to keep users productive, and underpinning compliance efforts like HIPAA, GDPR, you name it.
And crucially, integrating protection into those modern collaboration spaces like Microsoft 365 Copilot, which is becoming increasingly important.
Yeah, that ability to move from just blocking things to enabling work securely, that feels like the strategic shift organizations are looking for.
It's about finding that balance between robust security and enabling the business to function effectively.
So we kicked off by talking about defining risk tolerance as the absolute foundation, and we acknowledged that aiming for zero leakage might be unrealistic or even damaging to the business. What's a final, maybe provocative thought you leave with the IT leaders listening? What question should they be asking back within their organization?
I think the most vital ongoing question you need to challenge your stakeholders with is this. What is our specific, calculated, and acceptable tolerance for sensitive data leakage, really? Define it. Quantify it if you can. Is the primary risk financial loss, reputational damage, a regulatory fine?
Because knowing that threshold is what allows you to make smart choices.
Exactly. Knowing that threshold allows you to prioritize your protection efforts strategically, focus controls where they matter most, and make informed decisions about risk versus productivity rather than just trying to boil the ocean and block everything everywhere all the time. That definition should drive your entire DLP strategy and its continuous refinement.